everyone, welcome to Math Talk. I'm your host, Brian Heisler, and today we're going to continue to look at one of my favorite topics in mathematics, and that is number patterns and sequences. If you hadn't had a chance yet to check out my previous video where we looked at the arithmetic sequence, go ahead and do that. But if you have, we're going to go ahead and continue on with this video where we're going to look at another type of sequence, the geometric sequence. So let's get started. Part 2 of the patterns and sequences, the geometric sequence. So a geometric sequence is basically a sequence of numbers where each term after the first is found by multiplying the previous one by a non-zero number or a common ratio. What that really means is a geometric sequence is a sequence or pattern of numbers where to get from one term to the next, you're either going to be multiplying or dividing by the same number. So let's take a look at a couple examples. Here we have an example where the pattern or sequence starts at 2 and it goes from 2 to 6, 18, 54. So this pattern or sequence is increasing at a rapid rate, which means I'm going to be multiplying by a positive number. And it turns out to get from one term to the next, you just multiply by 3 each time. Because 2 times 3 is 6, 6 times 3 is 18, and 18 times 3 is 54. And just like with arithmetic sequences, you can continue this pattern of multiplying by 3 to find, the 10th, the 20th, the 100th term, or the nth term. So let's look at another example. In this sequence, we start out at 1,000, and you can see that as we go on, we decrease dramatically. There's 1,000 to 200 to 40 to 8 to 1.6. And one of the things you want to keep in mind is that if you have a sequence or a pattern that drastically decreases in value as you continue along, what that means is your common ratio is either going to be a fraction or a decimal, or you're just going to be dividing by a number. And it turns out in this one, to get from one term to the next, you just multiply by a fifth, or you just divide by 5. Because I prefer full numbers or whole numbers over fractions, I'm just going to say I'm going to divide by 5 every time. 1,000 divided by 5 is 200, divided by 5 is 40, divided by 5 is 8, and divided by 5 is 1.6. And just like in the last example, you can continue this pattern of dividing by 5 to find really any term in the sequence that you want. It's important to note here that even though your pattern is continuing to decrease in value, it's never actually going to be a negative number. You're never going to get a negative number in this sequence because you're always dividing positive numbers by positive numbers. It's going to get closer and closer to 0 as you continue along, but it's never going to become a negative value, and it's really important. Let's look at another example where that might not be the case. In this example, we have a pattern that starts out at positive 5 and goes to negative 10, then to positive 20, to negative 40, and to positive 80. So it's alternating between positive and negative values, but it's still, if you look at just the values of the numbers themselves, the 5, 10, 20, 40, 80, that is increasing itself, which means we're going to be multiplying by a number, but because we're alternating between positive and negative values, our ratio is actually going to be a negative number. And so I know that from 5 to 10, 20, 40, 80 is going up by a factor of 2 because it's alternating from positive to negative. My ratio is just negative 2. And as you can see, if I take 5 times negative 2, I get negative 10. Negative 10 times negative 2, I get positive 20, and so on and so forth. And this is a pattern that you can still continue on to find any term in the sequence that you want. You just have to remember that it's possible your value could be positive or negative, whichever term in the sequence you're looking at. They have to alternate every time, positive to negative. So let's look at some examples on how we can find the nth term in a geometric sequence. We have this example that asks us to find the 7th term in this geometric sequence. So as I look at this sequence, I see that it starts at 3, goes to 6, 12, 24, etc. So it's climbing or rising in value, which means as I look at my common ratio, it's going to be a positive number. And it turns out the number I have to multiply every time is 2. So I'm going to keep this common ratio in mind as I continue my pattern from 24 on. So 24 times 2 is 48, times 2 is 96, times 2 is 192. and that happens to be the 7th term in this sequence. Let's look at another example. Again, we're asked to find the 7th term in this geometric sequence below, but right away I can see that my numbers are alternating between negative and positive values. What that means is my common ratio I automatically know has to be a negative number. And so I can see that it's going up by a factor of 3, 1 times 3 times 3 times 3. So because they're alternating positive and negative, it's a negative 3. So I'll continue this ratio as I keep going through my pattern. 27 times negative 3 is negative 81. Negative 81 times negative 3 is positive 243. Times negative 3 is negative 729. So the 7th term in this sequence is negative 729. Okay, one more example. Again, we're asked to find the 7th term in this geometric sequence, and I can see that my pattern or sequence starts at a really large number, and it's dropping dramatically or decreasing in value dramatically, which ultimately means I'm going to be dividing by a number or multiplying by a fraction or decimal. And so when I look at my common ratio, I can try and figure out that factor, and it ends up that it's either multiplying by 1/4 or dividing by 4. And again, I prefer dividing by whole numbers as opposed to multiplying by fractions, so I'm just going to say we're going to divide by 4 every time. So continuing the pattern, 16 divided by 4 is 4, 4 divided by 4 is 1, and 1 divided by 4 is 1/4 or a quarter. So the 7th term in this sequence is a quarter. So I have another challenge problem that I want to present. I have a geometric sequence with 2 missing numbers. I want you to see if you can take the information you've learned in this video and see if you can figure out what those 2 missing numbers are. If you think you know the answer, write them in the comments below.
If you have any other questions or you need assistance and you live in the Palm Beach County area, visit our website at geds.com to find a location near you and sign up for classes.